Okay, in this video we are going to look at absolute value, and we're going to look at both equations and inequalities and how to solve each of those. For either one, we're going to follow basically the same three steps. First step, before we can do anything else, the absolute value part of the equation has to be by itself. So our first step is to isolate the absolute value. Then we're going to rewrite to get rid of the absolute value symbols. That's going to be a different procedure for equations and inequalities, but either way we have to get rid of those symbols somehow, and then we are finally ready to solve. So first up, we'll look at equations before we solve an equation. A quick review of absolute value. I think the best way to think about absolute value is it represents a distance, and the absolute value of x is actually the distance from 0. So, for example, if I told you that I lived 5 miles from here, you would know how far I lived, but you wouldn't know what direction. Absolute value is the same thing. It's a distance from 0. So if I tell you the distance from 0, the absolute value of x is equal to 2, you know how far away it is from 0, but you don't know which direction. It could be 2 units to the right, or it could be 2 units to the left. So the absolute value of x equals 2 is really two possible solutions. X could either be -2 or it could be +2. So this idea is what we're going to use when we want to rewrite our equations in our solving process. So let's look at this first basic one. Okay, step 1, isolate the absolute value. This one, the absolute value part, is already by itself. There's nothing over here on this side of the equation besides the absolute value. So we are ready to go to step 2 and just rewrite this equation without the absolute value symbols. And we would do that. You write down whatever is inside the absolute value symbols. Do not change that at all. You set it equal to the negative constant. And then you write it down again. Do not change those symbols. Set it equal to the positive constant, because absolute value is a distance. It could be -6 or +6. Once we have it rewritten here, these are always pretty easy solves once we get to this point. Subtract 6 from both sides, and then divide by that -2. We end up with x is 6. That's one possible solution. We needed to solve this side too. Divide by -2, and we get x is 0. So for this equation, our solution, x is either 0 or 6. Okay, for this next one, we'll do another equation. This one, the absolute value portion is not isolated yet. It's not the only thing on the left-hand side, so that's what we have to do first. So we'll start off by subtracting 2 from both sides. And then divide both sides by -5. And we end up with the absolute value of 5x minus 5 is equal to 15. Now the absolute value part is by itself, so we're ready to rewrite without those absolute value symbols. Same as the first example, take whatever's inside the absolute value, don't change it at all. Set it equal to -15. And then take whatever's in the absolute value symbols again, set it equal to +15. Here are our two quick equations to solve. Add 5 to both sides, and divide by 5. One of our solutions is -2. Same procedure over here on the right. Divide by 5, and our other solution is 4. So for this second equation we worked on, x could either be equal to -2 or +4. Okay, so the key thing to remember on these equations, first get the absolute value part by itself, then rewrite it, and that's where the plus and the minus part come in. When you rewrite it, you get the positive and negative versions of your constant right here. Okay, so let's look at some inequalities. Two cases, less than and greater than. the equal to's work the same. So less than or equal to, same procedure. Greater than or equal to, same procedure. So we'll start by talking about less than. Again, let's look just real quickly at the definition here. If we say the absolute value of x is less than 2, let's do less than or equal to. That means the distance from 0 is less than or equal to 2. So if we start at 0 and we want to count everything that's less than or equal to 2, same idea. We're going to have 2 and everything less, negative 2, and everything greater. So if the distance is less than 2, that means it's got to be between those two endpoints, positive 2 and negative 2. And we can rewrite this absolute value as an and inequality. X has got to be in between 2 and negative 2. So that's going to be an important form. We need to remember that less than is always an and inequality. That's going to be our rewriting step. For greater than or equal to, I think I'm going to write that down here because I ran out of room. Okay, now we're saying the distance from 0 is more than 2. It's greater than or equal to 2. So that means it's 2 and everything bigger. But it could also be negative 2 and anything smaller. So this time we get 2 sections shaded on our graph, and we have to write that as an or inequality. So we would, this is the same as x less than or equal to negative 2, that gives me the left-hand side, or x greater than or equal to positive 2, and that gives me the right-hand side. This is the important step for the greater than or equal to. We need to rewrite those as an or inequality. Okay, so let's do an example of each one of those. Here's our first one. This one is a greater than, so that means that second scenario we looked at, greater than means we're going to rewrite it as an or. But before we do that, we have to get the absolute value by itself, so we just need to quickly subtract 8 from both sides. Absolute value is now isolated, so now we're ready to rewrite. Any greater than or equal to gets rewritten the same way. Either what's in the absolute value has to be less than negative 9, that's the left-hand tail, or whatever's in the absolute value has to be greater than positive 9, that's the right-hand tail. Now we have 2 inequalities that we can solve. Divide both sides by 4. Oh wait, sorry, mistake there. Negative 9 plus 7 is not negative 9. That would be negative 2. So if we simplify, that means x is less than 1/2. We'll work on our other inequality. Again, add 7 to both sides. For x is greater than 16 means that x has to be greater than 4. This or goes in between because either one of these cases would solve our inequality. And we usually want to rewrite this into interval notation. So this first part would be negative infinity up to negative 1/2. That takes care of the x less than negative 1/2. We use a union symbol to join these two intervals. And x greater than 4 would be starting at 4 and going up to infinity. There is our solution for this inequality. And then let's also do a less than example. Remember, less than or equal to works the same way. Again, first step in all of these absolute values is to get that absolute value by itself. So we'll subtract the 8 from both sides. And then we'll divide both sides by 4. And then we're ready to rewrite since it happened again. I'm just going to keep going. I restarted the first time. I don't know why my values just disappeared there, but this is the second time I've tried it, so I'm just going to go here, divide by 4. Sorry about that. Now we're ready to rewrite. Okay, sorry about that. I had to pause the recording and fix my Word document. I don't know what happened there, but here, now we are ready to rewrite this. This is a less than, so that means we need to rewrite it as an and inequality. That means we take whatever's inside the absolute value symbols and we sandwich that in between a positive and a negative of your constant, in this case 4. So 6x minus 2 is less than or equal to 4, but it is also greater than or equal to negative 4. When we solve this three-part inequality, we add 2 in all three spots. And then we divide by 6 in the middle. Remember, when we're solving three-part inequalities, you leave your variable in the middle and move everything else out. So this solution tells us that x has to be in between negative 1/3 and positive 1. X is less than or equal to positive 1. It's also greater than or equal to negative 1/3. So that gives us an interval with square brackets, since we've got equal to's this time, from negative 1/3 to positive 1.